This next lab is a challenge for you to demonstrate what you've learned so far. And so I have a free body here, this ball, and then some kind of bracket with some holes in that bracket. I have a pinwheel here, and so the ball will go through the pinwheel. You might think of this as a counter on a production machine, and so each time an object goes through here, it increases that count. And there might be some kind of notification. In this case, we're representing that notification with this bell, so it comes in contact with that bell. So let's go ahead and play this one. And so the ball drops down. I'm also displaying a trace of the center point location of that ball. So these are some student examples. It contacts the pinwheel. Now we haven't put friction on any joints, but you might try to figure out how to put friction on this pinwheel so that it doesn't continuously rotate after it's been contacted. Same way with the bell, so that it doesn't continuously swing back and forth after it's been contacted. So that was one example. Let's look at another example. So come up with a design of your idea. The key parameters is I want it to go through and drop through a couple of different tracks, let's say 3 different tracks, and then ends in some collection area of your design. And on this one, the bell is hanging from a rope or string. You might make that really thin and going through the counter. So we have the tracks, the counter, and the notification. So let's go ahead and play this one. So I'll let you work on this, and then I'll come back and give you some tips on solving this problem. So this pinwheel has 1 degree of freedom, a revolution. So you should have a revolution joint on the pinwheel. For the bell ringer, if you put a spherical joint at this end and a spherical joint at this end, you'll get close to a representation. Now we have a rigid link in between those. We don't have an easy way of representing a flexible string or rope, but we can put a rigid link with the spherical joints at each end of that. Now you may run into an issue, an error that will say something like micromechanism model, because the string has very little mass. And so if I go into the simulation settings, if you get that micromechanism warning, click on here, and so again you'll get that. So it'll say a component has very little mass compared to the rest of the components, something like that. Check mark this micromechanism model, and don't forget that one.